So welcome to the video for Objective 4, topic of conservation of mass. Guys, this is really what we refer to as balancing chemical equations. In order to balance chemical equations, we first need to know the difference between a coefficient and a subscript. So a coefficient is a big number that is in front of an element or a compound. We will write down a couple of examples of coefficients right now in just a second. For right now, it'd probably be a good idea if this is new to go ahead and make yourself a note of that. Subscripts are little numbers to the right, which is after an element or compound. Both of these numbers are used to tell us how many of an element or compound that I have. So, for example, if I had H2O, what this tells me, first of all, is that this little number after the H is called a subscript. What this means is that if I tried to break this down into its pieces, I would have two H's because I have a little 2 right after the H. And then if we look at the O, we notice there's not any subscript at all. When this happens, we never put 0. Just like in algebra, where there's not a number, we always put an understood 1. Sometimes this could happen in parentheses. So if I have something like this, where I have OH2, it looks an awful lot like the first one, but the number of elements that we have is completely different. When I have a subscript or a little number outside of a set of parentheses like we do here, what this means is that this subscript goes to each element that's inside of these parentheses. So if I tried to break this out, I would have O2 and H2, because just like in math, whatever is in front of the parentheses goes to everything inside of the parentheses. So now that we've got a little bit about subscripts, let's do a couple examples of coefficients. A coefficient would be something like 4CO2. In this example, we've got both. We've got a coefficient, a big number in front, and a subscript, a little number off to the side. In order to figure out how many of each one of these elements we have, first we have to realize what is an element. The easiest way to do this is to look for capital letters. In chemistry, anytime we have a capital letter, we start a new element. So this is element number 1, it's C for carbon. Here's element number 2, O for oxygen. So if I was going to try to figure out how many of these I have, I would say C equals and O equals. The first thing I'm going to do is look at my subscript. Carbon doesn't have a subscript, so I say that there's 1. And oxygen has a 2 for a subscript, so there's 2. Then to deal with the coefficient, coefficients are always multiplied by whatever the subscript is. So to show this work out, I would say times 4, because I have a coefficient of 4. That means altogether I have 4 carbons. I would also do this one times 4, because this coefficient goes to every single element that comes after it. So I would say times 4 equals 8. The really important thing to remember about coefficients and subscripts is that I can always change a coefficient. It is always all right to change this number in front. It is never all right to change a subscript. Whatever the subscripts are, that's how they have to stay, no matter what. This becomes really important when we need to talk about balancing equations. So let's flip the page. It'll be a really good time for you to go ahead and find a good place to work. And we're going to say, let's see here, part 2, balancing equations. There are 2 ways to do this. I'm going to show you the first way as a part of this video, and then Z is going to show you another way as a part of the video that will come right after this one. It doesn't really matter which way you work the questions out, and we're going to do the exact same examples for both. As long as you get the right answer at the end, you can do it any way that makes sense to you. So the first thing we're going to do is write out our equation just like it's given to us. I'm just going to choose one that's reasonably easy to start with here. And the first thing I want to do using pen or pencil, it's probably best to do a pencil for this, but I'm going to use this marker so you can see it, is draw a line right through the middle of the equation. So we have a reactant side. These are like the ingredients. and we have a product side. This is like what we make. The easiest way that I think to do this is to use colors, and the easiest way for Z to do this, is to use algebra. So I'm going to focus on the color way. And that way looks like this. I choose a color, whichever one you want, and start identifying elements. P is phosphorus. It's a capital letter all by itself, so there's my first element, and then I'm going to come get the same element on the other side. You should always, always have the same elements on both sides, reactants and products. I'm going to look at the subscript, and there's not a subscript here, so I'm going to put a 1 underneath. That tells me I have 1 phosphorus on the reactant side. And then on the product side, I've got a subscript of 4, so I'm going to have 4 phosphorus. And then I'm going to choose a completely different color. So let's try yellow. I'm going to go through and I'm going to say, okay, the next element that I have is oxygen. And then I have oxygen again on the product side. Again, they should always match. On this reactant side, there are 2 oxygens. I know that by looking at the subscript 2. And there are 10 oxygens on the product side, given by the subscript of 10. In order to balance this equation, the whole idea is that the numbers should be the same on both sides. And right now, they are not. In order to fix this, remember we can never change subscripts. It would not be okay to put a little 4 right here. I can never change subscripts, but I can change coefficients. So I need to say, what number should I put right here in front of the P, that when I put that number and multiply it by 1, I'll get 4. If I put a 4 right here and I say 4 times 1, 4 times 1 is equal to 4. If I do that, then I have 4 phosphorus on the reactants and 4 phosphorus on the products. So now those match and I'm done. I don't need to do anything else. The next thing I need to do is look at my oxygens. I have 2 oxygens on the reactant side and 10 oxygens on the product side. These are not the same. In order to fix this, I need to add a coefficient in front of the oxygen. So I'm going to give myself a little coefficient line, and I'm going to say what times 2 is the same as 10, because I want this side and this side to be the same. 5 times 2 makes 10. So I'm going to put a 5 as my coefficient. I'm going to cross out my 2 because the total of 5 times 2 is 10, and now the reactants and the products match on both sides. The answer to this question, when I finally work it out, would look like this. 4P plus 5O2 yields P4O10. This is the basic way to balance an equation using the color method. If this way works for you, fantastic. You probably don't need to watch the other video. If this way doesn't work for you, if you're curious about the second way, I would definitely suggest checking out Z's way of solving these using algebra. Have a great day, and I'll see you in class.